Review chapter section 5 is on negative exponents and rational exponents. This section is going to focus on negative exponents. So if we have a base a that's not 0 and it's a real number, and if we take n to be a integer that's positive, then we have that base to the negative n. We can rewrite that as 1 over that base with n being the exponent. So since we're saying that n is positive, that means that we definitely starting out with a negative exponent, and if we want to write that exponent in a positive way, we're going to put that base in the denominator, right? We're going to take the reciprocal of it. So let's look at an example where we apply that. Start off with 3 to the negative 2. So our base is 3. So that says we're going to take the reciprocal of 3, so 1/3, and we put the exponent on that 3 in the denominator. So we get 1 over 3 squared, which we can simplify as 1/9. So another example, what if we've got a negative in front of that 3? Just remind us how we deal with these. So we have the exponent applying first. So the negative is going to stay out in front. So we have 1 over 3 squared with the negative out in front, so we end up with negative 1/9. Okay, let's look at this one. Let's say we've got 5x, that whole quantity in parentheses, with an exponent of negative 3. So in this case, the base for that exponent is that whole quantity, 5x. That whole quantity goes in the denominator. We take the reciprocal of it, and we apply that exponent of 3. So we can distribute that exponent of 3 to the 5. So we get 5 cubed x cubed, and simplifying that, we get 125 x cubed. All right, let's try this one. 4 squared y to the negative 3 x squared. One thing we can remind ourselves of here is that any negative exponent is going to put that base in the denominator. So we're going to have a fraction or a rational expression. The 4 squared is going to be in the numerator because that exponent is positive, and then the x squared is going to be in the numerator because we have a positive exponent. But the y has a negative exponent, so it goes in the denominator. So we end up with 16x squared over y cubed. Let's look at this one. The expression 2 over x, that whole thing has an exponent of negative 2. Okay, we can distribute that negative 2 to be an exponent on the 2 and an exponent on the x. Okay, so we've got a 2 in the numerator that's got a negative exponent. So we're going to put that down in the denominator with a positive exponent, and we have an x in the denominator with a negative exponent. So what that does, if we take the reciprocal of something that's already in a denominator, it puts it in the numerator. So we end up with x squared. And simplifying that out, we get x squared over 4. Okay, we're going to look at another rule now, the quotient rule for exponents. And it says, and we're always going to assume here that our base a is not equal to 0 and it's a real number. And we're going to always assume that our exponents, in this case we have 2, n and m, they are positive integers. So the rule says if we've got the base a to the exponent n over that same base to the exponent m, we can write that as that base a just showing up one time if we take n and subtract m as the exponent. So we subtract the denominator exponent from the numerator exponent. So example, if we've got a to the 5th over a cubed, we can write that as a to the 5 minus 3. So we end up with a squared. All right, let's look at this one. 3x squared over 5x to the negative 3. So the 3 and the 5, and we're not going to do anything with those. Those don't have exponents on them, so there's nothing to do. There's nothing to simplify there. But the x, we can go x, and we can say 2 minus a negative 3. So we end up with, in the numerator, 3, and then 2 minus a negative 3, that's 2 plus 3. So we get 3x to the 5th over 5. Okay, let's look at this one, kind of increasing sort of the complexity. 16 p to the 7th q to the 5th over 10 p to the 4th q to the 7th. Okay, starting off with the 16 and 10. No exponent on those, so we can just go ahead and simplify, and 2 goes into the 16 8 times and into 10 5 times. Now if we look at the p, we've got p to the 7 minus 4, and q is going to be q to the 5 minus 7. So we get 8 p to the 3rd and q to the negative 2, and then that's over 5. Okay, we're not quite done because we want to write with only positive exponents. So we've got that q to the negative 2. To write that exponent, to write that exponent as a positive, it needs to go in the denominator. So we get 8p cubed over 5q squared. Okay, one more example. 5x to the negative 3 times the quantity 3 to the negative 1, x to the negative 3. That whole thing with an exponent of 2. Okay, let's just take this piece by piece, starting with that 5x to the negative 3. Well, we can write that x to the negative 3 as the reciprocal of x to the 3rd, and so 5 would be in the numerator, so 5 over x cubed. All right, now let's distribute that let's distribute that positive exponent of 2 inside the parentheses. So it applies to the 3 to the negative 1. We multiply because we have exponent to exponent, so we get 3 to the negative 2. And then multiplying the negative 3 by 2, we get x to the negative 6. Okay, remember we want to write with only positive exponents. So we're going to need to write that 3 to the negative 2, that goes in the denominator, so 3 to the positive 2, and then the x to the negative 6, we're going to write that as x to the 6th in the denominator. Okay, so let's simplify that. 5 goes in the numerator. We have 3 squares. We can write that as 9. And then we have x cubed times x to the 6th. So we can write that as 1 base of x. Adding those exponents, we get x to the 9.